Alright guys, so this is a bit of a different video than my typical videos, but this is going to be a build video of a sort of deep learning machine because I'm only now getting into trying to mess with the AI stuff, and that's why we're going to build a machine with a 3090 in it. And I'm trying to make this portable, so even though I'm using a full RTX board over here and lots of RAM, which is the whole point of this build for, AI stuff, I'm still trying to make this portable. So I just decided to build this, and this is basically the smallest ATX case that you can buy that isn't boutique build like from Sliger. This is just a Silverstone case, the GD11. It's meant to be an HTPC case, but it's essentially just as tall as an ATX board plus a power supply. So this should be perfect for this build. And I thought I'm just gonna make some kind of a laid back and easy video that you guys can watch and see me build this PC with. So yeah, let's take a look at the components first. Obviously, I've talked about the case already. It's a Silverstone GD11 case, which is meant to be an HTPC case that has really nice ventilation on it. The only thing I'm a bit annoyed about is that it doesn't have a third fan on the front, which clearly they have space for if you have graphics card here, but they also have intakes on the bottom, so it's not really a big deal. But it's like I said, it's a really compact ATX case, which is actually even a great choice, even if you don't plan to build a semi-portable PC like this, or if you don't plan to build an HTPC. I still think this is a really good case for a gaming PC build, for example. And onto the next main component is this motherboard, which is the Asus Rampage 5 Edition 10. It's quite an old board. It's an LGA 2011-3 Broadwell and Haswell generation motherboard from X99 chipset. And the reason I'm using this is because DDR4 RDIMMs are getting really cheap these days. So I've got these Samsung sticks over here, which are actually a Samsung B die according to the spec sheet from what I've seen. And these are 256 gigs of them. And I only paid $200 for it, so it's really cheap. $200 for 256 gigs. I mean, that's incredibly cheap, especially compared to what Apple is charging for RAM, as you guys may know recently. 8 gigabytes equals to 16 in Windows or whatever thing they're trying to say. But yeah, I'm gonna pair this with the Intel Xeon 2679 V4, which this is a 20-core CPU from Intel. And it's not just a typical Intel Xeon from the LGA 2011-3 era. This is actually a very special Xeon that Intel made for eBay that has 20 cores and boosts all the way to 240 watts. Now, if you guys are keeping up with the X99 CPUs, like from Techia City or like Mycon's Hardware or something, if you guys are avid watchers of those guys, X99 is still pretty okay, but they are definitely getting old. And most of the CPUs are locked to 145 watts. But this one specifically goes all the way to 200 watts and up to 240 watts boosted. And that's because it's made for eBay. Not as in like it's sold at eBay. It's actually made for eBay. Like their servers run on these Xeons. They probably already upgrade at this point, but these were made for eBay, which is highly clocked Xeons with 20 cores with higher TDPs. And I accidentally found one on eBay, so I just had to buy it. And now it's going to be the main CPU for my deep learning AI workstation build here. And yeah, so 20 core CPU, 256 gigs of RAM, and a insane motherboard from Asus back on X99 days. And these are all pretty affordable. I bought the board for like $100 and the memory is like $200 for 256 gigs. The CPU is only like, I think $250, which is the most expensive part, but I just bought it because it's cool. It's a unique CPU. And the most important part is it has lots of PCIe slots, so I definitely can put more graphics cards in this. And speaking of graphics cards, like I said, I'm putting the RTX 3090 on here because, well, 4090s are still extremely expensive, but 3090s are still really fast for AI workloads, especially when you're doing tensor matrix multiplications on FP16, which is what you're using for most LLMs or even stable diffusion. And also, if you're trying to fine-tune those models, you definitely benefit from tensor cores and FP16. So the 3090 is still a really good GPU for that, and they're getting, I would say, downright affordable for AI workloads. I mean, I got this card for $750, which is still a lot for a graphics card, but that's a lot cheaper than it was back then when there was a shortage. And it's definitely way cheaper than a 4090, while only being a few percent slower and having the same amount of memory, which is the most important part. Most important part when you're doing some kind of AI training, where you need lots of memory. And yeah, that's basically the main component. So I'm just gonna put it all into this case, along with this really big power supply, of course. But yeah, let's get into it. And actually, I forgot one more thing. I got two 3090s. So yeah, we got these two cards to play with, and that's the reason why I need this board, which has the perfect spacing of PCIe, as well as the huge 1600 watt EVGA power supply. So I'm gonna use this CPU cooler because it's a 92 millimeter fan cooler, which is gonna fit just fine under this case. And it's actually a super micro cooler for their servers. So yeah, there's that. I gotta take the top off first to install the cooler. These are actually pretty nice coolers. They have like 5 heat pipes and a pretty thick heatsink. It's just that I don't know why they use aluminum on the base. I guess it doesn't matter on server CPUs because they're such low heat density. And even this Xeon that I'm using, it's 200 watts, but it's really easy to cool because 200 watts across like 20 cores is like only 10 watts per core. It's really nothing. But yeah, there you go. Just gotta put the paste on. Kind of like to just add extra paste on the sides for big CPUs. There's not really any disadvantage to using too much paste because it'll just squeeze out the side. Whereas if you use too little paste, then you can actually get some problems. So regarding the airflow in this case, by the way, I'm not 100% sure what to do yet. Although I know that the GPUs have to intake from the bottom, and these have to be exhaust because I wouldn't be able to put fans in the bottom, so I need to make the case somehow negative pressure. So this will be exhaust through the front. So that means it's gonna suck some air from the back, but the rear side is also where the GPUs exhaust hot air and the power supply. So this intake is around hot parts, so I'm not sure how well that'll work, but for now, that's what I'm gonna plan to do. So that's why I'm facing the cooler that side, because it's gonna suck air from the back. And also remember to do a cross pattern when you tighten your cooler, as usual. You won't really break anything, especially with CPUs that has an IHS these days, but it's just better in terms of the paste spread, and also you don't stress out your motherboard and CPU as much compared to if you just tighten down one side all the way before tightening the other screws. Actually, I'm gonna swap the fans first. There's no way I'm using these like crappy fans that, well, they're probably not that crappy, but they're slow fans, and I'm not gonna cool through two 3090s using really slow fans, so I'm gonna swap it with some Noctuas, the 3000 RPM Noctuas. So as far as I know, the whole point of this like front fan mount on this case is to house a 240 millimeter radiator for your CPU. So if you have a gaming PC build, this case is actually really nice in terms of airflow, because you can put your CPU cooler on here and it'll get nice fresh air from the front. And your GPU is also going to get fresh air from the bottom intakes. Well, not the bottom, the side intakes. And it'll give all the components fresh air directly, which is probably going to be as good as open air in this case. So yeah, I'm actually really liking this case. Although the main point of me buying this is because it's compact, and I'm just hoping it'll be enough to cool two 3090s. But it should be completely fine if I can pull enough negative pressure in the case using the front fans and pull some fresh air from the side there, straight to the GPUs. But yeah, I'm gonna need some Noctuas for that. So I'm gonna use my trusty Noctua fans, which I've used for a lot of builds before, which is why they're quite dusty. And they haven't died yet, even though I've run them at 100% for long periods of time, and they're still completely fine. These are industrial Noctua fans after all. I did have a few Noctua IPPC fans die on me, but I'm not sure that's Noctua's fault because two of the fans died the same way, and they're both on like Asus X99-M WS boards that I was using. I think the fan header on that board is kind of screwed up, which is why the fans died. But they died in a way that it just suddenly stopped spinning at all. Like, as in, it doesn't look like it's getting any power, even if I plug in straight to 12 volts. So yeah, I don't know how that happened, but somehow it seems like my motherboard's killed two fans before. But hopefully this board doesn't, because that would suck. And it basically takes forever to screw them in, but these Silverstone screws seems pretty nice. But yeah, there you go. I put the fans on. They're gonna run as exhaust through the front of the case. Alright, seems really easy. And we can do the front panel and the fan wiring. Alright, let's just put in the GPUs because that's the most interesting part. Should probably wipe off the PCIe connector too, just in case it's dirty, because sometimes that causes connection issues. Although this shouldn't be that bad. I cleaned the card already, except for the smudges on the backplate, which I'm not sure why. It's probably because they tried to put some heat sinks on it. Is it 3 slots? Yeah, it is 3 slots. Alright, in theory, this should fit. Okay, so I got this thermal probe, which connects to the thermal sensor connector on this Asus board. And actually lots of their high-end X99 boards also have this, which is really nice because you can control the fans using this thermal probe, like somewhere where it gets airflow from the GPUs, and you can know when the GPUs get hot and speed up the case fans. And I'm just not sure why it's not a more common thing, because it's so stupid these days that case fans are just controlled by the CPU, where the highest heat output is actually these days from your GPUs. So it's really great to have a thermal probe monitoring system on your board. But yeah, let's finally plug in the GPUs. Hopefully this fits. No, it's getting stuck. I've been slotting it into the wrong position, so I couldn't bend it back. Hopefully this side it'll actually go in. This is getting somewhat annoying. There we go. Very nice. Yes. Now it's in. Okay. So just to make sure you guys know what I'm doing here, the GPU has to slot in behind this metal bar. I was slotting it in front of it because I thought those like tiny slots are for the PCIe brackets, but that's how you're supposed to do it. So yep, there you go. First GPU in. Gonna put the second brand new one on top because that's what I want to see. I don't want to see the old one. Although I should probably put in the SSD first, because that's gonna be under the GPU. Okay, so I got this XPG SSD. It's a 2 terabyte PCIe 4.0 drive that does like 7 gigs per second, but I'm just using a PCIe 3.0 motherboard, so all that bandwidth is gonna be completely useless. But it's a pretty nice SSD, so I'm not too fussed about it. That's all I care about.
and I don't really need the speed. And I just wanted an SSD with a heat spreader that is not like a really tall heatsink fan, because a really tall SSD is just going to interfere with the graphics card. But yeah, here we go. Time to put in the other 3090. Can't really see, it's kind of dark. Shit. Okay, here we go. Okay, let's see. Alright, 3090 going in. There you go. Two RTX 3090s in the build. Absolutely massive cards that just takes up the whole space. Forgot to switch the bit size back after changing the SSD. Okay, cool. So the only thing the 3090s are missing are basically the NVLink bridges, because I haven't bought them, and I had RTX Titans before. Yeah, I've got these at a good deal as well, but I sold it and essentially traded it for the 3090s. These are still really fast cards for machine learning, because they didn't artificially limit the FP16 performance of the tensor cores. Whereas on GeForce cards like the 3090, they did limit it so that it doesn't beat the RTX A6000, but it's only by a little bit, and it's still faster than RTX Titans, which are basically 2080 Ti's with 24 gigs of memory and a bit more cores. These are really awesome, and it looks freaking amazing with the gold. But I mean, if I could switch to 3090s, why wouldn't I do that? It's much faster. And also Ampere supports different feature sets such as BF16, bfloat 16 compute, which is good for saving memory when you're doing machine learning tasks. And also, I think it supports flash attention 2 for LLMs mostly, which is really important when you want to train with only 48 gigs of memory, because the RTX Titan doesn't support flash attention 2, or rather flash attention 2 GitHub repo. You can check it out. It doesn't support the Turing cards like the RTX Titan, so that's why I'm switching to the 3090s, and hopefully I'll be able to train larger models on the 3090s than on the RTX Titans. But for those, I did have a NVLink bridge. It's an EVGA one, but it's not the same as on the 3090, so I can't use it, which sucks. Plus, yeah, I sold these already. I'm just gonna have to back it up and ship it. But now I have the 3090s, which are faster, I guess, which is nice. But yeah, let's continue. I guess the last part would be just putting in the power supply, which I will install over here with the fan facing in, because if I face it out, the fan doesn't actually align to the intake because the power supply is so huge. So I'm just gonna make it face inside, which is just fine, not a big deal. The power supply fan barely even runs, so not like it's doing anything most of the time. Yep, yeah, this case is pretty compact. I think it's only like 33 liters, but the amount of hardware that you can pack in here is essentially as much as any other ATX case. You can fit a full-size eATX board like this, or even an SSI EEB board with like dual CPUs, and obviously these massive GPUs. And also the largest power supply you can fit in an ATX case also fits in this case, so it really is a versatile case. You can pretty much stuff anything you want while being somewhat reasonably sized. So I'm gonna have to sort out the cables here. These are nice braided cables, but these are CPU. And the thermal probe can kind of just hang out somewhere. Oh, I can just put it in the exhaust fans. Okay, that's... There we go. Perfect. Thermal probe right on the exhaust, so it, takes the temperature of whatever the exhaust air is. And if it's hot, it'll speed up the case fans. Okay. Good enough. This can go in between the fan connectors. This is really enough. There you go. Oh, this thing is getting heavy. Shit. Okay. So you don't have cable management holes on this case because it's all a single chamber, which is why it's so compact. But now you have to use this like super annoying zip ties. But hey, it's nice that they even include this, I guess. Okay, there you go. Hopefully the fans doesn't eat their own cables. Okay, should be fine. And the USB 3 can just, I don't know what to do with this. These are the most annoying cables. Yeah, the GPU power. Power cable adapters. Alright. Hopefully these don't melt like the 4090s. Funny enough, I don't really hear 3090s melting their power connectors, even though 3090s actually pull more power than the 4090s, so that is kind of interesting. Okay, nice. Okay, I think that's pretty much it. That's the build's pretty much done. Now all I gotta do is power it up and see if it actually works, because like I said, I haven't even tested the motherboard. So hopefully it's not dead, because then I have to swap it out, which is gonna suck. But yeah, here you go. Full build. Dual RTX 3090s with a 20-core CPU, 256 gigs of RAM, 2 terabytes for the SSD. And in terms of the airflow, my plan is to suck air from the bottom and blow it across the GPUs since it's flow-through design, and the rear fan's gonna blow most of the air out the back. and then exhaust the hot air from the GPUs through the front and suck in some cold air from the rear through the CPU. But yeah, we'll see how all this does once I actually put it together running. So that's what we're gonna do next, see if this works, but cool. Alright, so I got it working, the system's up, and I'm quite surprised that it just booted up without issues with the ECC memory, especially I plugged in all 256 gigs and a weird CPU that's not technically officially sold by Intel to the public, but it booted right up. So the Asus Rampage 5 Edition pen is actually just as good as the WS in terms of supporting the ECC and the Xeon, I guess, because it works just fine. And I'm now updating the BIOS to the second latest edition, the latest non-beta BIOS from the Asus website, because the latest one is just a beta BIOS where they applied the Intel Spectre fixes, which I don't really care for. So I just use the second to last one, the 1903 version, and we'll see how it goes from there. But yeah, otherwise it looks great. Just gotta turn off the RGB probably, because I don't like RGB. And yeah, gotta turn down that fan because that's super annoying. So I've been using the newly built PC already for training some 70 billion parameter LLMs, and yeah, it's been working great. It runs a bit loud, as you can hear probably in the background, but yeah, I could probably fix that by changing the fan curve in the BIOS, because I think it is, I set it too aggressively. It doesn't need this much RPMs, because the GPUs don't actually even get that hot, which is quite surprising to me, because the second GPU is like sucking in hot air from the first one, but I guess the sheer amount of airflow and because the GPUs themselves have such huge heat sinks, it's not really an issue and the temperatures are just fine. I mean, running this 70 billion parameter training, I could only run using naive model parallelism, which is that the GPUs only run one at a time sequentially, like back and forth. So it's not 100% load constantly, and that's probably why it's cooler. The top GPU is only running at like 60 degrees and the bottom one like 55 degrees. If I'm running a different workload that maxes out both GPUs, the top one can get close to 70 degrees and the bottom one is in the mid to low 60s, which is still like really good temperatures. Again, like I said, I'm quite surprised by how well this is cooling itself, because I just have these exhaust fans on the noctuas sucking in the hot air out and then just passively intaking cold air from all the vents, like from the bottom here to the GPUs and also to the back through the CPU cooler, and it seems to work just fine. But yeah, I guess this is somewhat of a resounding success for this PC build, because this is as compact as I could build for an ATX case. As you can see, the 3090s also just barely fit with the power cables. If you put the top cover on, it's definitely pushing it down a little bit. Although the power connector, luckily on the 3090, the 16-pin connector is angled, so you're not actually putting that much stress into it, which is great compared to like the 4090s, where the 16-pin just comes out straight out, and if you have a case covering it right on top of it, it's gonna squeeze it too much, and that's when you get the melty and burny 4090 issues. But otherwise, for this one, the 3090 is actually perfect. Also, I swapped out the power supply, if you notice, to Corsair HX 1200, because the EVGA one is kind of overkill and it's also extremely huge and heavy, which kind of defeats the purpose of this being sort of portable. And I did plan on, I mean, I already bought like a sort of duffel bag to put this whole PC in, and the plan is to bring it as a carry-on on planes, which this will fit, because the maximum carry-on size for I think most airlines is like 18-inch by 14-inch, which this fits exactly perfect without the front bezel. So I just have to take this off and put it in a bag, and it should zip up just fine and fit in a carry-on space. But yeah, it's been working just great. And the fans slow down, by the way, because it's taking temperature reading from this thermal probe. And if you open the case, obviously it's sucking in cooler air and slowing down. But I could probably just use this fan speed, honestly, when it's not doing such a heavy workload like this, and it's completely fine. It's not quiet, but I don't need it to be, because I'm gonna put it somewhere where I don't really care about the noise. So it's not my first priority. It's more of better just keep it cool. But yeah, I don't really need the maximum fan speed like you heard just now. So yeah, I would say this is a successful PC build, and I hope you guys enjoyed watching it and seeing me run this PC with the dual 3090s right now, and it's been working great. Hopefully I get the full usage that I wanted out of these, training AI models and trying to run them as well. But yeah, let me know if you guys want to see me make a video about which GPUs to get for training AI, for example. That might be also an interesting topic because I've done a lot of research, which is how I got to get these Titan RTX, and as well as now getting the 3090s, eventually swapping them to the 3090s. But yeah, thanks for watching.